Thank you. Yes, I'm going to talk today about the two cultures of programming. So if you're familiar with the two cultures, a slightly different riff on the concept. But before we jump into the content, just curious, out of everyone here, simple show of hands, who here considers themselves a scientist primarily? Okay, and who considers themselves a programmer primarily? Awesome, we got like a pretty even split, which is what I was hoping for. How many of you are tired of all the linear algebra and we're just looking for the non-technical session on the schedule? I have to say, I did propose talks, I think at both prior Julia conferences that were technical and didn't get picked, and then I realized the secret was do the non-technical talk at the technical conference. Anyway. Okay, so I wanted to give you all a little bit of background about myself, only because it sort of plays into the topic at hand. So I actually started programming in '91 on an Apple IIe. I had Apple IIe, Basic Manual, Go. And by the time I got to high school, I had discovered Linux. I recompiled my first kernel. And a couple of years later, I realized that you could actually do something other than recompile a kernel on Linux, which took a little while and was a bit of a revelation. And so up to that point in my life, I was kind of going down the path of a programmer. Except that in '98 I entered university, and in 2002 I graduated with a Bachelor's of Science in Chemistry. I was a scientist. And like all good scientists, I went to graduate school, right? Because, I mean, what are you going to do with a Bachelor's in Chemistry? But somewhere along the way, I ended up being a server software engineer at Apple. So programmer. Then got my degree in chemical biology, so back to scientist. And then I looked at the salary schedule of postdoctoral grants from the NIH and decided to become a software engineering consultant. And shortly thereafter discovered Julia. So this is the sort of point of view that I take to Julia. And I hope that this sort of split between science and programming will help to explain why I'm talking about what I'm talking about. So what is it that I'm talking about? Well, I'd like to propose to you a thesis that a good scientific programming language will also be a good general purpose programming language. Now, I don't think this is necessarily obvious at first, but I hope by the end of the talk to have you mostly convinced. Now, in this thesis statement, there is a hidden question that we must address first, and that is, are these even different things? Do scientists and programmers program differently? Now, if like myself, you've had a foot in both camps, you may already have an answer in mind. If you haven't, I'll give you a little bit of time to think about that. While we go on a slight tour of history. So in 1959, there was a fairly famous lecture given by a scientist and novelist, C.P. Snow, at Cambridge. Not this Cambridge, the other one. And the lecture he gave was called The Two Cultures. He later published the content of the lecture in a book, added a little bit to the title, followed it up with a sequel a couple of years later, and then made it a trilogy. But in essence, what he was talking about was that the academic world, as far as he could tell, split into two camps. On one hand, you had the humanities, and on the other hand, you had the sciences. And he felt that this schism was a bad thing. That, in fact, the more cross-fertilization you could get between these camps, the more problems of the world that you could solve. One of the things I always found interesting about the Two Cultures talk is that, as I mentioned, C.P. Snow was across the pond in England when he gave the lecture. And if you read closely what he said, The English perspective was that the humanities were held as the loftier pursuit. And at the time he gave the lecture, most primary schools in England were still teaching Latin, composition, music, art, whatnot. And the sciences are kind of an afterthought, right? And he felt that it was inappropriate for those in the humanities to disregard the sciences because the sciences could teach them something, namely the scientific method. Around 40 years later, that was really, I think, borne out by, if any of you are familiar with the work of Jared Diamond, for example, who applied the scientific method to the study of history, and his famous book, Guns, Germs, and Steel, or I always get those transposed, is a very, very enlightening read, and a real revelation on what happens when you do apply the scientific method to studies that are typically considered more in the humanities camp. What I found interesting, though, is that when I was first exposed to the two cultures, I was going through the American academic system, and the American perspective is kind of flip-flopped, right? Americans have always sort of held the sciences as the loftier pursuit, and scientists tend to disregard the humanities. There was a time in America where in order to get a PhD, you had to be fluent in 3 languages. Yeah, that got tossed out pretty quickly. Because many in the sciences felt that you should focus your efforts on the study of science, and humanities was just something for people who couldn't hack it as scientists to study. But again, that really is sort of doing a disservice to science, because after all, after you make a discovery, it's not really any good unless you can communicate it to the rest of the world. So if we look at how this schism originated, what it really seems to stem from is a focus on short-term goals. The humanities have as their primary goal the understanding of humans, it's right there in the name, and how humans relate to the world around them. Whereas scientists have as a primary goal the discovery and elucidation of these immutable laws of nature that describe everything that surrounds us, right? But in fact, if you take a step back and look at the larger picture, really, both camps have as their goal the pursuit of knowledge, right? We want to increase human knowledge. And so this was C.P. Snow's motivation for the lecture, was to try and wake people up and have them realize they needed to cross the aisle, they needed to take cues from the other side, and in doing so, they'd be able to advance human knowledge at an even greater pace. Okay, so back to the question I posed before. Do scientists and programmers program differently? Well, if you haven't come up with an answer yet, I'd like to sample just a couple of ways in which I feel they do differ. In case you didn't catch on, I do think they're different. That's why I'm giving the talk. So the first one that immediately pops to mind is tooling. If you're learning to program from a general purpose programmer, shortly after Hello World, you're likely to be introduced to things like source control, editors. As you proceed and learn more, you're going to learn things like debuggers and profilers. It turns out the tooling surrounding programming is almost as important as the programming itself. On the other hand, if you're a scientist, tooling seems to be such a foreign concept that you can actually publish an academic paper just describing 10 simple rules for taking advantage of Git. Another area where I feel there is a bit of a gulf between scientists and programmers is how we organize our code. Now, anecdotally, my PhD advisor had been doing polymer and protein modeling for at least a couple of decades. And almost every single program he wrote consisted of a single Fortran file, multiple thousands of lines long. Never saw the need for more than one file. But that's an anecdote. Can I back it up with anything? Well, I decided to take a look at probably one of the more popular general purpose programming frameworks, so Ruby on Rails, and look at how they organize their source code. And I should mention, this is actually just a sample. I couldn't actually go the full directory depth or length because it would never fit on a slide. But I think that this should hopefully illustrate that for the developers of Ruby on Rails, the organization of the source code within their package is very important and very neat, right? Not to pick on anybody, but it just so happens one scientific programming package that I'm familiar with from my work is Cell Profiler. And this is their full directory listing with the full depth. Now, you may say, well, Ruby on Rails is certainly huge compared to Cell Profiler. Not really. Ruby on Rails is only around 200,000 lines of code. Cell Profiler is around 150. So they're not that different in terms of code size, but there is a gulf of difference in how they've actually decided to organize themselves. Now, I don't mean to pick on the scientists. I do actually think that there are certain things that scientific programmers do better than general purpose programmers. And the main point I think I can pull out for that is prioritization. Right? If you've ever worked with a scientist writing a program, they are always concerned about the results, right? Get me the results. Get me to the results. The reasons they don't care so much about tooling or care so much about code organization is because they're trying to write a program that gets them results so they can move on, right? General purpose programmers tend to, well, there's a famous quote that most general purpose programmers will have heard of by the time they've been programming for more than a year or so. This is from Donald Knuth. He says, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Who's heard that? Premature optimization? Yeah, okay. Premature optimization is the root of all evil. He said this because he knew programmers have a tendency to take their code and polish their code and reorganize their code and prettify it and continue working on it with very little real-world results. There's really not much difference, right? So I do think general-purpose programmers could learn something from scientists in how to prioritize their work. But there's a second part of this quote. I don't know if you're familiar with it. Immediately afterwards, he says, yet we should not pass up our opportunities in that critical 3%. So there are some times in programming where optimization is important. And again, I think this is somewhere where scientists could teach a thing or two to programmers, because scientists have the scientific method. How are you going to optimize your program? Well, you could look at it, say, that's a for loop that looks expensive, and optimize it away. But did you do anything? Unless you actually tested it. How would you know? Right? So an application of the scientific method is key to proper optimization of your code. And I should mention debugging as well. The whole idea of a null hypothesis and a control, you'd be surprised how many people debug and don't actually check to make sure that the bug is still occurring. All right. So at this point, it's probably clear my point of view. In the world of the two cultures, I tend to equate programmers with the humanities. But it's not just me. In fact, in 2014, at the RailsConf keynote, David Hennemeyer Hansen gave what's actually a rather engaging talk, where he made the point that science is the wrong term for what most programmers do. And even software engineering is the wrong term for what most programmers do. His argument was that most programmers working today are software writers, and that they would do well to borrow more from the novelist than from the bridge builder. More recently, there was an interesting blog post I came across. Richard Gabriel wrote a rather detailed, this is just the first line, rather detailed sort of argument for teaching software development in the style of a Master of Fine Arts instead of how it's typically taught as a Bachelor's of Science, which I thought was really interesting, right? So again, I think there are two cultures, and again, I think that the schism stems from a focus by both camps on the more immediate goals. Scientists tend to view programming as a tool. Just like the Bunsen burner or the beaker, what's the point, right? If you just get the results and move on, there's not really any need to pay attention to the code. Programmers are almost the exact opposite. They view the software as the artifact of their work, right? How many of you have ever heard, "You are your code"? Or conversely, "You are not your code," which is the argument that sometimes people use. The idea that programmers would even think about equating themselves with their code sort of speaks to how they view their immediate goals. But again, if you zoom out and look at the bigger picture, we're all just trying to make the computers do stuff. So just like C.P. Snow's original argument back in 1959, I would make the argument that we will get much more done if scientists and programmers work together towards a common goal. Okay, now, if you buy that argument, good. If you don't, maybe I can convince you with a few more slides. Why would you care about getting programmers to use a scientific programming language or learning from scientists as a programmer? You might say, for example, scientists have large programming packages, right? Think NumPy and SciPy are two programming packages with which most of you should be familiar. And indeed, in terms of numbers of lines of code, they're very comparable to Ruby on Rails. In fact, SciPy is larger. But in terms of number of contributors, there's no contest. Now, some of you may think, sure, but linear algebra is far more difficult than web programming. to which I would say, you go try and write a web server. Obviously, there's something about general purpose programming that has enabled Ruby on Rails to engage a far greater section of the populace to help with making light work. Many hands make light work, right? You may have heard of a company named after a fruit that has espoused for a number of years the notion that they exist at this very intersection of the two cultures, right? This is actually a slide from one of their presentations. And I would say, based on the success of their products and the bottom line, that's a pretty good argument in favor of trying to join the two. Maybe you don't care about making products that make billions of dollars, though. Maybe you just want a job. This was an article that I loved. And it came out, I should say, shortly after I found out that this talk was accepted. Perfect timing. It was an article in The Economist. I don't know if you can see the subtitle there. It says, "Professors' unprofessional programs have created a new profession." The entire article is about how there are now cadres of professional programmers who are going around to universities and finding professors who have written these 10,000 line long single Fortran files and turn them into code that can actually be maintained, right? Now you may be thinking, if you're a programmer, great, more work for me. But I would argue that if we take a more sort of altruistic view of things, wouldn't it be nice if we didn't have professors generating mountains of spaghetti code in the first place? And finally, the reason I think you should care about this, the reason I care about this, the reason I'm even here giving this talk, is that, honestly, after around a decade of searching and sort of 2 years of pondering, I honestly believe Julia could be the language that unifies the two camps. Can be, not is. I think there is still work to do. Now, I want to emphasize that I am not trying to prescribe a list of things that need to be done. I'm hoping, perhaps, to start a discussion. So in that vein, I picked 5 items. I had a much longer list, but wouldn't have fit in time. So I pared it down to 5 areas that I feel could begin this discussion, and hopefully it will continue beyond this session and even beyond JuliaCon, and that we can eventually work towards making a programming language that is both the best scientific programming language and the best general purpose programming language. Okay, so to start off, Pkg.generate. I love Pkg.generate. I think that this is one of the greatest things I've seen in any programming language, because programming languages like C, C++, even Java, you can sort of excuse them for not giving perhaps the proper importance to community. They're a bit older. The software engineering world was a bit smaller when they came into being. But in this day, if you are starting a new language and you do not bake into the very foundations of that language the notion of community, then I think you've already failed. So I really love how Pkg.generate embraces the importance of community to any programming language. But again, I feel that even just the naming of it, in addition to the mechanics of it, belies a little bit of the disconnect between scientific and general purpose programming, because it's not just packages that need to be generated. If you look at most other programming languages, most other programs that people write, for example, Ruby on Rails, there is a function, a method, a command line tool that you call to start the project, right? I've seen a number of times on the mailing list, on Reddit threads and other places, people asking, well, Julia looks great. Where do I start? Right? Well, with a text file. Okay. And where do I put the second one? So I think, whether it's a separate Pkg.generate function that we create, or, and this will come in with a later slide, oh, actually, no, I took that slide out, sorry. Or perhaps even just Pkg.generate could fulfill both purposes, and we just need to think a little differently about what it means to be a package.
I don't understand. What does a project give you? What's the difference?
I'm sorry?
What is a project?
So the idea of a package is that when you generate the package, it's basically structured the code to be a library, to be consumed by something, right? Whereas, for example, in a Rails program, you start a new Rails program, it's structured to run. You say Rails new, and then you say Rails run, and you have a running application, right? You can't really run a package. I mean, you can, but it's awkward, right? Okay, readability. I love Unicode operators. I actually think that this is something a little unconventional that Julia got right. For in, I find to be actually slightly less readable than using the mathematical subset notation, so long as you're familiar with what that is, right? Not equals is so much easier to read when you actually have a not equals, as opposed to, was it bang equal or slash equal or equal slash equal or... No. So I do think that they are a good thing, but I do think they can be abused. And more generally, and again, you know, I didn't have enough space to get into more specifics, but I just wanted to put up this Martin Fowler quote because I feel that it's really important and something that scientists would be sort of very likely to overlook. He said, "Any fool can write code that a computer can understand. Good programmers write code that a human can understand." Right? We tend to forget that when we're focused on immediate results. It's not just about modifying Julia to fit the community or to fit some arbitrary goal, though. I do think there are certain things that Julia has gotten completely right, and it is the community that needs to fit the language. So array indexing comes up all the time, and will probably be one of the first things that any general purpose programmer brings up to you if you tell them to program in Julia, right? We have arbitrary indexing now. That's great. I love that. I think when general purpose programmers discover that, they're going to eventually catch on. But today, most of them say, one-based indexing, ugh, right? And they'll probably pull out a URL from the University of Texas written by Edgar Dijkstra, whole long diatribe about why arrays should be zero indexed, to which I say, I don't know how many of you have ever met Dijkstra, but you probably know that arrogance in computer science is measured in nanodijkstras. That was Alan Kay, who is no slouch himself. So, testing. When you're running a program once and generating results, and you can immediately compare those results to some sort of expected outcome, testing tends to take a back seat. So it's nice that Julia does have test and test throws. It's a good start. But for example, if you look at Ruby, these are just the unit test frameworks that it has available. Okay? Get into acceptance testing and all the rest of that, and there's even more. And last concrete point I wanted to make was the REPL. I love Julia's REPL. That you can access the shell, that you can access help, that you can modify it so that you can write C++ code right there in the REPL. That's great. But there's an important caveat here. Because lots of languages, like for example R, right? I have a bit of a confession to make. I used R for my PhD. I didn't actually save a single line of R to a file. I just sat at the REPL, typed in something, it generated a plot. I used the up arrow, modified it a little bit, generated a plot, right? That is not how general purpose programmers will use REPLs, right? So it's not enough to just have a good REPL. You have to have a good REPL that integrates with the workflow of a developer, right? Part of this workspace, again, brilliant. I love it. But method redefinition, the infamous issue number 265, that could use fixing. And finally, just to wrap up, one thing that I've noticed being in the programmer camp as opposed to the science camp that is easy to miss if you are in the science camp, I think, is just how much programming languages are defined by their communities. And so really, it is the community that needs as much engineering as the language. You have to be very cognizant of how you treat each other, who you invite in, who you ignore, who you don't ignore, how you engage with people, because that will ultimately shape the language as much as any grammar or parser or debugger. And with that, I'd like to thank you and take any questions you might have.